BRUFMA is the British Rigid Urethane Foam Manufacturers Association. Established in 1978, it represents manufacturers across the spectrum of rigid polyurethane, or PUR, and polyisocyanurate, PIR, insulation products produced in the UK. PU is the generic term used for both types of products. BRUFMA's membership comprises the major companies in the industry, including manufacturers of finished insulation products and suppliers of the various raw material components, many of whom are household names. The aim of this presentation is to give you an understanding of why insulation is important for buildings, both new and existing, how the industry calculates the insulation efficiency of construction materials, the superior insulating properties of polyurethane products, what PU is and how it's made, the other important properties of PU, including fire performance, its use in controlling noise, and its role in extreme weather conditions, the wide range of applications PU products offer, how PU products relate to building regulations, the sustainability and the environmental impact of PU products. Insulation is one of the most important considerations in the specification of a building. With as much as 26% of a building's heat lost through the roof and 33% via the walls, insulation helps maintain a comfortable indoor temperature for the people using the building. Greater energy efficiency means that less energy is needed to either warm or to cool the building. In turn, this leads to lower fuel consumption, lower energy bills for the consumer, and fewer carbon emissions to damage the environment. Whether a building is old or new, ensuring its fabric is well insulated is one of the cheapest and easiest ways to improve its energy efficiency. Provided the right insulation product is used and installed correctly, it will carry on being energy efficient over the life of the building, and any upfront costs are recouped in just a few years through the savings made on energy bills. The motivation to ensure new buildings in particular are built to be as energy efficient as possible include concerns over climate change, rising energy costs and concerns over energy security, UK legislation including the Climate Change Act and building regulations, government initiatives like the Green Deal and Energy Company Obligation. Deciding which insulation products to use can be confusing, so it's important to use the same scales of measurement to make a proper comparison. Thermal conductivity is the property of a material to conduct heat. It is often referred to as the lambda value. It is the rate of transmission of energy through 1 cubic meter of material with a 1 degree temperature difference on both sides. The lower the lambda value of the insulation, the better. However, in the UK construction industry, an R value is often quoted. This is a measure of thermal resistance. The R value measures the effectiveness of the insulation material and enables direct comparison between different materials. It takes into account both thickness and thermal conductivity. A higher R value indicates a better performing insulant. From this graph, you will see the thickness of different insulation materials needed to achieve the same R value, a particularly important consideration when space is an issue. Each of these calculations becomes important when choosing which insulation product to use and in making a U value calculation. U values help predict the behavior of an entire building element, such as a wall, roof, or floor, rather than relying on the individual properties of materials. They are usually requested to demonstrate compliance with building regulations and take into account the performance of all of the components of a construction element through their individual R values. The lower the U value, the better the performance of the building, since less heat is transferred. Rigid polyurethane, PUR, and polyisocyanurate, PIR, insulation products, or PU products as they're collectively known, are highly effective and lightweight and many have the ability to bond to most materials. Their excellent thermal conductivity and high strength to weight ratio, combined with a great manufacturing versatility, provides a wide range of products for most construction insulation applications. The first commercial applications for polyurethanes were developed in the mid 20th century. Since then, they have been finding use in an ever increasing number of industries, including construction, automotive, refrigeration, furniture, and footwear. Polyurethanes are extremely versatile and are found all around us in many everyday items. Rigid PU insulation products are made by reacting a liquid polyol with a liquid polymeric isocyanate, known as MDI, in the presence of a blowing agent and other additives. The mixed components then react exothermally to form a rigid thermosetting polymer. Since the blowing agent evaporates during this reaction, a rigid closed-cell low-density insulation product is created. Excellent insulation performance is achieved because the gas trapped within the closed-cell structure has a very low thermal conductivity, and there is minimal heat conduction through the solid cell wall due to the low density. Approximately 97% of the volume of the foam is trapped gas. Rigid PIR differs from PUR due to the slight variation in its chemical composition. PIR has increased fire performance and higher working temperature limits compared to PUR, and when installed into building products, it can meet some of the most demanding requirements. PIR is generally used in the manufacture of factory-produced board products, whilst PUR is for specialist applications such as cavity wall injection and spray foam applications. Not all insulation is the same, and it's important to understand the differences between the products available in order to make an informed choice about which material to use. The very low thermal conductivity of rigid PU insulation products is one of their most important properties, making them one of the most effective insulation solutions for many applications. Here, we can see the comparative thickness of several building materials and insulation products to achieve an R value of 5. The benefits of superior thermal insulation performance offered by PU products are wide-ranging and extremely valuable, including the amount of space that can be saved by using them, the reduction of greenhouse gas emissions, and lower energy bills for consumers. Other benefits for construction professionals include reduced transport costs, ease of handling, a safer working environment, and improved construction times. But it's not just the thermal performance of an insulant that needs to be taken into account. Rigid PU foam products have remarkable mechanical strength too. High compressive and shear strengths allow low density, highly efficient insulating cores to be faced with thin, flexible, or rigid materials. This additional strength is especially important when installing insulation on flat roofs, where they're often exposed to dynamic mechanical loads. For example, pedestrian traffic during construction or maintenance phases. After a few loads, some materials can lose their compressive strength and thus their insulation performance. This occurs because of the shape of the individual foam cells, which tend not to be spherical but more cylindrical or egg-shaped when examined through a microscope. In terms of fire performance, PU insulation products meet a wide range of fire performance requirements as stipulated by current building regulations and the insurance industry. Insulation is almost always used behind a barrier, such as plasterboard, bricks, blocks, or roof decking, and is normally only a minor contributory factor in fires in buildings, so its fire performance should be considered as part of the construction as a whole. The building contents are often the major contributors to such fires. Although it is classed as a combustible material, PU insulation does not smolder, melt, or drip when heated. PU insulation systems exceed the fire safety regulations and insurance requirements for a wide range of applications, and where high fire performance is needed, suitable products can be specified. Products are available which meet Class 0 of the UK building regulations when tested to BS 476, Parts 6 and 7, and Class 1 surface spread of flame performance when tested to BS 476, Part 7. In the new Euroclass system, where products are classified from Class A, non-combustible, through to Class F, no performance determined, PU insulation products are able to meet up to and including Class B when used in their end-use application. PU can play a part in acoustic and stabilization performance. Where houses situated within aeroplane flight paths have suffered from high-level airborne noise pollution, this has been successfully treated by insulating the underside of roof slates with a spray-applied PU product, creating a permanent bond between the tiles and the roof structure. The foam-sealed roof helps prevent vibration, offering sound reduction properties. Furthermore, it increases the insulation properties of the property to building regulation standards, thus reducing energy usage and costs as well as greenhouse gas emissions. The cost of repairing windstorm damage is currently running at over £825 million per year and is expected to increase as a result of climate change. This cost is normally borne by insurance companies, and such is the impact of these costs that the insurance industry has been looking at preventative measures, and it suggests that sprayed PU could be used to bond tiles or slates to the roof structure to prevent them from being dislodged in high winds. Flooding is also increasingly making the news, and the choice of insulation is important here too. In a report published jointly by DEFRA, DCLG and the Environment Agency, rigid PU is shown to be the best performing when installed into cavity walls because it retains its integrity and has low moisture take-up. Alternative materials, such as mineral fibre bats, can remain wet several months after exposure to floodwater, which slows down the wall drying process, and blown-in insulation can slump due to the excessive moisture uptake. Closed cell insulation is also recommended when installing floor insulation in order to minimize the impact of floodwater. PU products are extremely versatile and can be used across a wide range of sectors, including residential, healthcare, and education. They also cover a variety of applications, from cavity wall insulation, pitched and flat roofing, internal and external wall insulation, floor insulation, as well as pipe and duct insulation. Whether it's a timber frame building or masonry cavity wall, PU insulation makes it easy to achieve the U values needed. But it isn't just inside the walls where it can play its part. PU is also suitable for use internally as insulated plasterboard or externally behind a render finish. Being thinner than most other insulants, it has a major advantage over other insulants when it comes to making the most of available living space. It also plays its part in the non-domestic sector and can be used in steel frame buildings and rain screen cladding. Cavity-injected insulation not only provides excellent thermal performance, but expands to bond the outer leaves together, thus stabilizing the walls, a particularly effective treatment for corroded cavity wall ties. Many households have had traditional cavity wall insulation installed, but there are still huge numbers of properties which are considered hard to treat. For a variety of reasons, including the age of the property, the way it was originally constructed, or the risk of ingress of rainwater into the cavity from severe wind-driven rain or flooding. High-performance closed-cell PU cavity wall insulation can be used in all these situations. The use of rafter-level insulation is rapidly increasing to create a warm roof space which can be used for storage or as a room in a roof. PU boards offer flexibility in that they are versatile enough to be used over, under, or between rafters or in combinations such as between and under or between and over. They can be used in both new build and refurbishment projects. Their use means that the pitch of the roof can be insulated to current standards without sacrificing valuable headroom or the additional expense and inconvenience of deeper joists. Installing PU products above the roof timber has multiple benefits. Having insulation over the rafters reduces the risk of cold bridging and, provided a breathable sarking membrane is used, offers the opportunity for an airtight construction. The number of new pitched roofs that are insulated at rafter level is increasing all the time. PU is the most commonly used insulation product in flat roof applications in the UK because of its excellent dimensional stability and compressive strength. It is also lightweight and easier to handle than other insulation products. The best way to eliminate ponding from a roof is to introduce a fall, and using tapered PU insulation is one of the most cost-effective methods of doing just that. It's also significantly lighter than screed and dries relatively quickly. There are several types of flat roofing which might be used on a construction project, including built-up systems, which are used to create warm roof solutions, single-ply membranes, insulations for balconies and terraces to enable use by foot traffic, and insulated decks, such as garage roofs. Because of their superior thermal performance, PU products offer one of the thinnest solutions available in a floor construction. One great benefit of the thin solution achieved with PU insulation products is the reduction in the depth of excavation required to accommodate the floor structure and the consequent reduction in excavation material removal. The financial saving of just 50mm depth across the floor area of a building can be considerable. Floor insulation can be used on concrete slab floors, in solid floors between screed, or in suspended timber floors between joists, in conjunction with underfloor heating systems, ensuring that valuable heat is not lost downwards through the structure, in suspended ground floor insulation, and in a range of industrial and commercial applications. Spray insulation can maximize energy and carbon savings and is a cost-effective and versatile way to insulate all kinds of areas, including awkward and hard-to-reach spaces like roofs. The material forms a continuous even layer with no joints or gaps, eliminating thermal bridges and draft proofing in one application. Because of its versatility, it can be used with all types of building designs and is applied directly onto the substrate by a specialist contractor. With tighter regulations for buildings being introduced into England, Scotland and Wales and Northern Ireland, the need to specify higher performing products has never been greater. Specifying the best performing insulation is the most cost-effective way to make energy savings over the lifetime of a building. By adopting a fabric-first approach, building regulations can be met using insulation without the need to add efficient services and renewable technologies. England and Wales are each covered by their own version of Approved Document L, whilst Northern Ireland is covered by technical booklets F1 and F2, all of which deal with the conservation of fuel and power. Each nation sets out its own U-value targets within the relevant documents. Scotland is covered by Section 6 of the Scottish Building Regulations, which deals with energy within the built environment. The new Part L 2013 for England became effective from the 6th of April 2014 and calls for a further 6% reduction in CO2 emissions for domestic buildings and a further 9% reduction for non-domestic buildings compared to 2010 requirements. The 2013 edition also requires the building designer to meet a second target called Target Fabric Energy Efficiency, TFEE. This places greater emphasis on a fabric-first approach, ensuring that the U values of floors, walls, roofs, windows and doors, as well as thermal bridging and airtightness, stay within the specified target. And for the first time, those homes with the most fabric, such as detached houses, will need to reduce more emissions than those with less fabric, such as mid-terrace houses or flats. The Scottish regulations differ in that for new buildings, the various building parameters are entered into a computer program to give a CO2 emission rate. Each time the regulation changes, the allowable carbon emissions targets are tightened. The 2010 regulations have been tightened by 30% over 2007 requirements, and in 2015 they'll be tightened again by a further 21% for domestic buildings and 43% for non-domestic buildings over 2010 rates. Environmental considerations and costs performance are two of the main selection criteria for the specification of construction products. Along with social performance, they also represent the three pillars of sustainable development. Policymakers, industry, non-governmental organisations and end users agree on the need for the construction industry to move towards more sustainable building concepts and designs. Where they differ is deciding on how sustainability can best be assessed and which tools should be used to enable builders, specifiers, architects, or policymakers to make more informed material choices. The European Trade Body for PU Europe, commissioned studies by the Building Research Establishment in 2010 and PricewaterhouseCoopers in 2013 to quantify the overall environmental and economic costs of using PU and other insulation materials in low-energy building designs. In summary, the conclusions were: insulation is a key contributor to sustainable construction. Insulation materials contribute little to a building's overall environmental burden. The most common insulation materials show a very similar environmental performance when assessed at the building level over the whole life cycle. Insulation choice should be based on its ability to provide the highest energy performance at the building level and maintain specified performance levels over the whole life cycle. PU insulation solutions in low-energy buildings offer low life cycle costs and can be more cost-effective than other insulation solutions. When considering the life cycle of a product, it is important to consider resource efficiency, a subject which BRUFMA and its members take seriously. Recently, they have been working with waste reduction experts RAP to create an action plan for all parties involved in the production, handling, or otherwise influencing building insulation foam waste. Its main objective is to divert higher levels of these wastes away from landfill and ensure greater efficiency in resource use across the construction supply chain. There are a number of generic issues relating to resource efficiency relevant to all insulation product types. For example, the scope to design outwaste arising from the installation of board products relates more closely to the way the building is designed than to the product used. In terms of site practices, some manufacturers offer waste take-back schemes, but going forward, it is important that the conditions to segregate and collect all the waste types are conducive to maximising the opportunities to recover these resources. And so to summarise, rigid PU insulation has some of the lowest lambda values on the market. Rigid PU insulation products are suitable for most construction insulation applications, including those deemed hard to treat. PU insulation solutions in low-energy buildings offer low life cycle costs and can be more cost-effective than other insulation solutions. Rigid PU insulation products have excellent mechanical strength. Rigid PU insulation products can offer protection against windstorm and flood damage. Injected PU insulation provides a superior thermal performance whilst helping to stabilize walls. PU can be used to easily and effectively introduce a fall to a flat roof. PU floor insulation reduces the depth and cost of excavation. Thank you for watching this presentation. If you require a certificate for your continued professional development portfolio, please visit www.brufma.co.uk/CPD_certificate.